Today we will see the response of parallel RC circuit to triangular voltage input. Consider an RC circuit. Resistor is 1 kilo ohms, capacitor is 500 nanofarad. Input is a triangular voltage with time period 1 milliseconds and amplitude 1 volts. Now since R and C are in parallel, the voltage seen across resistor and capacitor will be same as input voltage. We want to find the current flowing through the capacitor. Now the current flowing through the capacitor can be calculated using the equation IC of t is equal to C into dVc by dt. Current flowing through the resistor will look similar to input voltage because IR is equal to V in or VR by R. During the rising slope, it will have a constant positive slope. Then IC will stay at 1 milliamperes. During the falling slope, it will have constant negative slope and hence IC drops down to minus 1 milliamps and stays there until the next rising slope. Same calculation for IC is repeated in Excel with time interval of 500. Same calculation for IC is repeated in Excel with time interval of 5 microseconds. Let's look at that. So here we can see that this is the input voltage that you are feeding to the RC circuit. Resistor is 1 kilo ohms, capacitor is 500 nanofarads, and we can see how IC is calculated as it is equal to C into dV by dt. Here on plotting IC values, we can see how the graph looks like. So the input here has rising and falling slope. So it will have constant difference between the 2 points considered. So the slope will be a constant positive slope during the rising slope, and then IC will stay at 1 milliamperes. That is why initially it raises from 0 and stays at 1 milliampere because this slope will be constant. And then during the falling slope, it will have a constant negative slope and hence IC drops down to minus 1 milliampere and stays there until it sees the next rising slope. IR is equal to VR or VC by R. All of this IR and VR or VC looks similar to input voltage because it is parallel to resistor and capacitor. IR is nothing but VR by R and hence it looks similar to the voltage across resistor. Let's simulate this and check. Now on simulating this, we can see that this is the input voltage that we are feeding, which is same as the voltage across capacitor and resistor. This is how the current flowing through the capacitor looks like. This is the current flowing through the resistor. Here is the summary. We can see how the input triangular voltage, which is fed to parallel RC circuit, has transformed the current flowing through the capacitor. If the time constant of RC circuit is comparable to input's time period, then it will not resemble the behavior for triangular voltage input. Thank you for watching this video.